أحييكم دكتور مصطفى الأدور من الجامعة الألمانية، وبعد دقائق هتبدأ فعاليات بداية هذا الحدث الذي ننقله على القناة الفضائية المصرية، ويحضر عدد كبير من الأساتذة والعلماء.
I'm very delighted to welcome my colleagues and guests from Germany, and it is a great pleasure to be there with us. And thanks Alexander von Humboldt Institution for their contribution, as well as you have heard the story between GUC and Germany. I will not repeat. I'm also proud that I am DAD alumni. I have also my PhD from Stuttgart. And we have really started long away in order to achieve what we have seen, or you will be seen, or visiting also. Invite you to find, or to see the industrial park, to share with us this success story in Egypt. I am very glad about the speakers. Maybe that is another examples how utilize basic science to be implemented in Africa to control malaria, as we will see. But of course, there was a lot of challenges. We suffered. It was not an easy job. But the problem of research in Arab world, of course, it is not money. It is a system. If you have the system, you will succeed. If you don't have, no way. The science behind this innovation, I'm talking also because that is Egyptian innovation, really. And the science behind it is simply the first law of thermodynamics, what everybody knows about it, that the energy can be created, cannot be created or destroyed, but can be changed from one phase or from one form to another. That is the basic concept of this. And if we're talking about energy, we have the solar spectrum, which the red color here, it's about 50%, which is really near infrared. That is the heat coming from the sun by 50%. And the most important region, the visible light, that is really the direct or the indirect sunlight, which we can see each other, or we have the photosynthesis process, which produces the oxygen or the life of the equation of the life, and the small amount of the ultraviolet, which could be escaped from the stratosphere phase in the world. All the coming applications, it depends on the photochemical conversion, which is mainly, in very simple form, conversion of light to chemical energy. And what exists exactly in the plants. We will see the total organic mass plants by photosynthesis. It produced 3 × 10⁻21 joule per annum yearly. We found this. And this value, it's 10 times more the annual world consumption of energy. This means that photosynthesis in the past produced fossil fuel, as you know, natural gas, oil, and so on. And the organic mass which is utilized now to save this energy, it is 10 times what we need. But unfortunately, what the total incident of solar irradiance, it is 10 to the power 24 joule. This means that even the total organic mass, it represent not more than 0.1% of the solar incident irradiance in the Earth. This means that we utilize only 0.1% from the solar energy received by the sun through the photosynthesis. And you can imagine if you want to increase this ratio instead of 0.01, 0.015, it will mean breakthrough. But even this small amount, it represents 10 times. But how far we are utilizing the solar energy, unfortunately. The light could make chemistry, that is the photochemical conversions, exactly what chlorophyll is doing. Absorb the light from the sun, fix it CO2, and they take water from the ground, and then producing the oxygen, what we producing, as you know. And that is exactly one of the best applications, what we call it photodynamic therapy, to kill or to diagnose and treat cancer. We'll see soon. And the other things, light could be dissipated to heat, and that is exactly what is the nanotechnology is doing. The golden nanoparticle, you know the work of Professor Mustapha Sayed. Laser light will be scattered by the golden nanoparticle. If the golden nanoparticle exists in tumor cells, it will produce a very strong heat. And this heat, due to reflection or sometime of also some absorption of light, and this will kill the cells. Photodynamic means the conversions of light to chemical energy, and light can produce heat. And if you imagine that here we wanted to kill, that is tumor cells, and we wanted to kill these tumor cells, we need interaction of light and substance sensitizer which absorbs the light. And if it absorbs the light, it will convert the triplet oxygen state, the ground state oxygen, to singlet oxygen. If it produces singlet oxygen, it will be very aggressive species, and it will kill the tumor cells. Say if this is the target, that is tumor cells. If the interaction proceeds not in proper way, this means that the pigment will absorb the light, transform the triplet oxygen to the singlet oxygen, and if this is not incorporated in our target, nothing will be happening. This means that the challenge of the scientist to introduce or incorporate the pigment which will be incorporated in the target. Now this target is the tumor cell, say, and if the light shines, it will produce the triplet or transfer the triplet to singlet oxygen, which is aggressive species, leading to cell kill. Or the biological says reactive oxygen species attack this and producing either free radical or singlet oxygen transformation. That is all the science behind the implementation, what I'm going to talk about it. The mechanism is a little bit more complicated than this, but by all means, what we need pigment. We call it sensitizer to absorb the light. We need light, especially in the lab or in the body of the patient who had some problem or the tumors. It will be laser, but if we are talking about malaria or to kill noxious insect, of course, we should look for the sun, not for the laser. And then we need oxygen to be produced as active oxygen species, as the biologists say. And then we have what is called the type 1 electron transfer process, or electron transfer producing free radical or energy transfer process produced the end result is forming apoptosis or necrosis according to the type of the reaction. The tumor cells will accumulate this. This means that after 2 hours, you will find that all the pigment will concentrate where the tumor exists. Then it is easy to make recognition or recognize or make diagnostics. If you illuminate this with laser light, the pigment, as I told you in the first slide, light will be produced and the fluorescence could be used as a tool for diagnosis. So even if the surgery wanted to take part one of the tumor cells, he should do this experiment in order to see to what depths the tumor exists or the size, the area, and so on. Even more than that, the light could make the therapy, make the treatment by producing singlet oxygen or free radical as explained, and then it will kill the cells in molecular levels. That is the photodynamic therapy. And if you believe me or not, I have just 2 slides about the diagnostics. Okay, now it doesn't work. Then you will see here patient which has some skin cancer tumor. It does not good recognize, but if you use sensitizers, you will see how it looks like after illumination, and he can now the doctor recognize and determine exactly the size and the depth of this. Cancer in this esophagus, and if you are able to just penetrate light or illuminate this with endoscopy, and then according to what I have explained, this pigment will concentrate only on the where the tumor cells exist, and if you illuminate, you will have free radical or singlet oxygen, and this is the way, and that is the companies now producing a huge number of technologies, or that is the fiber optics which is used here to penetrate the lights in order to deliver the light in proper way. And here that is the photo how it looks like this cancer in esophagus, and here you will have the patient, and you see here it is really very simple, or you can say office operation, you call it in medical office operation in one day, and you can get rid of such very complicated cancer by utilizing BDT. This technology, I'm not, it is not my research. It started with a collaboration between the basic science, physics, chemistry, and then implemented by the physicians, and it is now implemented in the clinic everywhere in the world, unfortunately not yet in Egypt. And I hope that we can make the awareness of that, because it is very important, and that could be integrated to chemotherapy as well as to other tools of cancer diagnosis and therapy.